So now we're going to do an example. I'm going to try and prove tangency using our knowledge about the discriminant. So we're asked to prove that y equals x squared, 5x minus 2 is a tangent to the parabola of y equals 2x squared plus x. Okay, and then we're asked to find the point of intersection. Well, we know that b squared minus 4ac equals 0 for a tangent. Okay, so then we can use this to our advantage to solve this problem. So we've got 2x squared plus x equals 5x minus 2. So 2x squared minus 4x plus 2 equals 0. Divide everything by 2. X squared minus 2x plus 1 equals 0. Okay, and now we can use our discriminant information. So we know that b squared minus 4ac should be equal to 0. So let's check it here. Well, b is minus 2, so minus 2 squared minus 4 times 1 times 1. So that equals 4 minus 4 equals 0, okay? So that proves tangency. So therefore, line is a tangent. A tangent. Okay, so we're not quite finished yet though. It says, and find the point of intersection. So how are we going to do this? Well, we need to find the x point and then we need to find the y point. So how can we do that from here? Well, we can just factorize this expression. We know that it's going to be a double root. So what's going to add up to negative 2 and multiply to make 1, that's the same number. Well, it's minus 1, so x minus 1 becomes x minus 1 equal to 0. So this is x minus 1 squared, same thing. So x is equal to 1. So we know x is equal to 1. So we just substitute that into our equation for y. So y equals 2 times 1 squared plus 1, which equals 3. No, it doesn't. Equals 2 plus 1, which equals 3. So the point of intersection is just 1, 3. Okay, so let's try another example. So find the equation of the tangent to y equals x squared plus 1 that has a gradient 3. Okay, so this sounds a little bit confusing, but if you think about it, so we've got an equation which is y squared plus 1, which would be something like that. And we want to know the equation of the tangent that has a gradient 3. So gradient 3 is going to be something like this. So basically we want to know the equation of this line. Okay, and we know that a straight line is going to have equation of y equals 3. No, we're going to skip ahead there. Y equals mx plus b, right? So, or plus c even, doesn't matter. And then you know that the gradient here is going to be 3. So now you have an expression for your line, you have an expression for your curve. You can make them equal to each other. So it becomes x squared plus 1 equals 3x plus c. And then you just move it all over to one side, x squared minus 3x plus 1 minus c. And we know that it's a tangent, right? So now we need to use our knowledge of the discriminant again. So I'll change color here to make it more obvious. So we want b squared minus 4ac equal to 0. So this is a, b, and c here. So this becomes minus 3 squared minus 4 times 1 times 1 minus c. It's got to be equal to 0, okay? So this becomes 9 minus 4. 4 times 1, then plus 4c equals 0. So 4c equals, well, 9 minus 4 is 5, move it over, negative 5. So c is equal to negative 5 over 4. Okay, so now we have an answer for c. All we need to do is substitute this back in. So y is equal to 3x minus 5 over 4. That's a final answer. So it's just an example of how you can use tangency and knowing something's a tangent or proving something's a tangent to help solve a problem. But there'll be more examples in class and stuff like that.